Right, so the altitude of a triangle. The altitude is the height. It's the line which goes through one vertex of the triangle and is perpendicular to the opposite side. So you can see on triangle ABC here, we've got vertex C, and the height of the triangle is opposite side AB. So if we were working out the area of this triangle, it would be a half times this length of AB multiplied by the height, which is the length of CD. Now, in this obtuse triangle, you can see that the altitude's actually outside the triangle, but it's exactly the same process. It's going to be the gradient of QR, which is the side that's opposite vertex P. So to find the equation of the altitude, step one, we're going to find the gradient M1 of the opposite side from the vertex, so AB or QR. We're then going to find the perpendicular gradient M2 of the altitude by using our relationship M1, M2 equals -1. And step three, we're going to substitute the vertex, so in this case it would be C or P, into our equation of a straight line y minus b equals m upon x minus a with our perpendicular gradient that we've just calculated. So let's have a go at an example. The diagram shows triangle ABC, and we want to find the equation of the altitude through A. And you can see that it's been drawn in for you in a red line here. So it's our perpendicular altitude. So step one, we need to find the gradient of the side opposite vertex A. So we're working out the gradient of BC. We want to work out MBC by finding the difference in the y coordinates. So that's going to be 1 minus 0 divided by 3, take away -5. And that's going to give us a gradient of 1/8. Now, we remember our relationship for perpendicular gradients. M1, M2 equals -1 for perpendicular lines. So our perpendicular gradient going through A is going to be, flip our 1/8 to be 8, and then change the sign. So this was positive, and this is negative. And looking at our diagram, that makes sense, because again, our gradient is sloping down in a negative way. Then, final step, we're going to write down the equation of our straight line, y minus b equals m upon x minus a. And we're going to substitute in this coordinate here. So our a value and our b value are coming from coordinate a. So we've got y, and our b value is -4, so it's going to be y plus 4 equals, our perpendicular gradient is -8, and that's upon x, and it's 2 for our a value, we're going to take away 2. So that gives us y plus 4 equals, and then we need to expand our bracket, -8x, and it'll be plus 16, because -8 times -2 gives us a positive answer. Now we need to gather our like terms, so let's move everything over to the left-hand side. So we're going to get y, and we're going to get plus 8x. We're going to take away 16 from the 4, so we're going to get -12, and that equals 0. So the equation of the altitude through A of triangle ABC is y plus 8x take away 12 equals 0. So our fact for altitudes when they're concurrent is that they go through a point called an orthocenter. Now, just like the altitude didn't have to necessarily be inside the triangle, the orthocenter can be outside the triangle too. So you can see In triangle STU, point X is our orthocenter inside our triangle where the three altitudes meet. For triangle ABC, our point X for our orthocenter is outside of our triangle where all the altitudes meet. But this is just an interesting fact and not something that you'll be examined on. So, classwork, exercise 1.7, questions 1 to 4 are your priority, extension, question 5. If you need any help, just ask.